Hello students, today we will discuss about how to determine wedge angle and thickness of spacer in a air wedge experiment. So as we have discussed, the air wedge is a wedge shaped film formed between two glass plates, where you can see two glass plates inclined on a spacer. So the ends of the glass plate will be touching at one side and the other will be inclined. So when you see, you have a microscope to observe the fringe pattern, and first of all you have a source of light, a point source, which will be made parallel. As you know, extended source is required for um, this particular kind of interference, where the coherent sources are obtained by amplitude splitting. So in that case we require extended source or broad source. For that case, what we do is that we make it parallel, and that is incident on a glass plate, and it gets fall which is kept at an angle 45 degrees, so that it can fall, the light can fall on the glass plate normally. And why are we keeping the source at the sidewise? It is just because so that after reflection we will be able to observe it. If the source is also here, we won't be able to make our observation. That is why we have kept it sidewise. Okay, so what is happening here? That is the experimental setup for here. And how do you get it? So what is happening behind us, this is the air wedge, that is upper layer of the film, and this represents the lower layer of the film. Okay, so in this region you can see that when the light is incident on the glass plate and finally reaches the upper layer of the film, it gets reflected. Okay, and from here also it will get reflected. After that, some portion will be transmitted into the film, and from the lower layer also you will get reflection. Okay, so we'll be able to get reflected rays from the glass plate also, but what we are interested is we want to see fringes. So the fringes are formed or for a sustained interference case. And how do you get a sustained interference? That will be possible only if the thickness of the film is comparable with the wavelength of the light that is incident. That is the case for a thin film. So here if you consider visible light, the order of wavelength is in the order of an average order, you can say it is for green it is 500 nanometer, isn't it? But what would be the thickness of the glass plate? Glass plate maybe some 3 millimeters or so on, isn't it? So what happens is that the millimeter, and one is in millimeter and other is in nanometer, are they comparable? No, they are not comparable. So though the reflection happens from the glass plate, it doesn't lead to any interference. Okay, and what about this one, the air film? We have mentioned that it is a very thin sheet that is kept as the spacer. So the angle subtended over here will be very small, okay, less than 1 degree or so. Okay, that means the thickness of the air film will be very much smaller, and it can be made comparable to the wavelength of light. Okay, so you'll get proper reflection. And another fact to be pointed out is that these rays, when they are incident on the inclined plane, after reflection they will be like diverging outside. Okay, so they seems to be diverging from the lower surface and the, let me draw again, so they seems to diverge from upper and the lower surface. Okay, so if the thickness of the film is so small, is made small, then the amount of diverging can be decreased. Now let me draw with another color. So the amount of diverging, if the thickness is very small, then this might be the point of the reflection from the upper layer, and let this be the point of reflection from the lower layer. So then you can see that if I consider very small portion of the film or thickness of the film, the amount of divergence of the reflected rays are less compared to the thicker film. Okay, so if the reflected rays are close enough, you will be getting proper superposition, thereby proper fringe pattern. And this is what we observe. So that means we have to use a microscope, because these fringes will be lying very close to the top surface of the setup. And this is the fringe pattern we will be getting. As we have mentioned, it will be straight line. Why? Because as we have mentioned earlier, the thickness, if we consider the entire glass plate, the thickness will be constant along the line parallel to the apex. Which is the apex? Apex is the contacting point of the glass plate. So any line which is parallel to the apex will constitute same thickness. So here also this particular thickness will be obtained throughout the line across the glass plate, which is parallel to the apex of the setup. Okay, so another point is that, so we'll be getting a straight line as we have mentioned in previous class. So using the microscope, we'll be coinciding with any one particular fringe. Let us consider mth order fringe, and from the microscope we are able to know what is the position in the scale. And then after that we'll move on to some nth number. So it will be total of m plus n fringe, and the distance will be x2. So these two can be measured using the microscope, and we will be carrying on with the further calculation. So knowing that, how do we obtain it? So this is the position we have mentioned. So the first fringe was noticed, and it was noted as, we don't know what is the order of the fringe. So let us take it as nth order fringe, and the distance is x1, and thickness of the film at that point is t1. And then we are looking at another fringe which is n order differing from the first one considered, and whose thickness is t2, and distance measured using microscope is x2. So considering that, we can make use of the condition for dark fringe for a reflected system, which is 2 mu t1 is equal to m lambda for mth order fringe with thickness t1. Similarly, for the fringe m plus n fringe at the distance x2 and thickness t2, you can write it as 2 mu t2 equals m plus capital N into lambda. And now let's take some geometric steps evaluation. So let us consider this particular triangle O, Q and P. Okay, or P, Q and O, where Q is the 90-degree point. Okay. So in that case, you can see T1 is the opposite side of the wedge angle, and you know x1, and that is the adjacent side of the wedge angle. So you can use the trigonometric ratio, opposite side by adjacent side is given by tan theta. So it is T1 by x1, and since the theta is very small, you can approximate that theta to tan theta to theta itself. So finally what you get is T1 is obtained as x1 theta. So you can replace T1 over here with x1 theta. Okay, similar thing can be done for the next order fringe also. We are considering a bigger triangle now, O, then S. Okay, so let us consider this point as S. So O, R, S, or S, R, O. Okay, anyway it is. So here also you can write T2 by x2 is the tan theta, and approximating, you will be getting it as x2 theta as the thickness. So substituting those two, the relations, first relation, second relation can be rewritten, and you just have to take the difference of these two equations. So then what will happen, n will be the only term remaining, m and m lambda will cancel off. So from that we can write what is theta, that is wedge angle, that is n, that is the number of fringes we have moved, and lambda is the wavelength of the light used, and mu is the film refractive index, and since it is an AF film, mu will be 1, and x2 and x1 is measured using microscope. So all the values are known and we can easily calculate the wedge angle. Okay, and question can also be asked how you can measure the thickness of the spacer. Okay, so same thing it is, only thing is that we have to consider a big triangle this time containing the thickness of the spacer as the opposite side of the wedge angle. So then what will be the adjacent side? Adjacent side will be given by length of the glass plate. So considering that, you can write tan theta is equal to thickness divided by length of the glass plate, or thickness of the spacer will be L into theta. Theta is already known, you just have to substitute it. So that is how we will be determining. So if the question is asked how to determine wedge angle or the thickness of the spacer and give a proper experiment, you have to first mention about what is a wedge, and then you have to mention what is the interference happening in the wedge, and then you have to mention what is the method of getting the current source. Then the next point is what is the path difference involved, and then you will be getting the beta as we have calculated last time. So then you can mention about the features of the fringes, and after that you have to mention about the experimental setup. Then you have to consider how to determine theta, and if it is asked to find out thickness, you have to mention about the case of thickness also, otherwise you can end up with theta. So that ends the chapter on interference. Thank you.